Okay, so let's start. Okay, last thing I talked about last time was Hess law. What is Hess law?
Doctor, we can't see your screen.
Oh, okay. I did not change this. Okay. Okay, can you see it now?
Yes.
Good.
Yes.
All right. What is Hess law?
The law that we combine the heat of the multiple reactions.
Yes. To make a certain reaction. This is what's Hess law. Hess law is to use reactions to make a reaction. Like, for example, this case here. Look at these three reactions. This is reaction 1 plus 2 plus 3. 1. We know the reaction, the heat of reaction 2. We know the heat of reaction 3. All right, but we don't know what's at this time. Suppose that we don't know this number here. Suppose that this number we cannot see. Okay. Can we calculate this number? Yes, we can. How? If you look at these three reactions, if you add these three reactions together, you will keep NO as is, O as is, NO2 as is. But O3, which is reactant here, will go with O3 in products. So this will be gone. Also, 3/2 O2 in reactant will go with 1 O2 and half O2. Total is 3/2 O2. And that's why they also cancel with each other. Okay, and so what's left with us is only this reaction. The heat of this reaction is to add these three numbers together. Add them in your calculator. Yes.
Minus 304.1.
0.1. Okay, and let's see. Yes, it is 304. So that's how you do, that's Hess law. Keep this in mind. Hess law is to use many reactions to make one reaction. How many reactions you should use? Is it 2 or 3 or 4 or what? Anything. We don't know. Maybe 2, maybe 3, maybe 4, maybe 5. We don't know. Clear? Is this clear? Good.
Yes.
Next, let's go to another topic, which is called standard enthalpies of formation. Okay, what's the meaning of formation?
تكوين.
Making, right? Or التكوين, yes. التكوين, making. All right. Heat of formation. What's the letter we use for enthalpy?
H.
H. And since this is called formation, we will call it F. Clear? And when we say standard, we're going to put a circle here to make it standard. So we're going to talk about HF delta. What's this letter? Read this.
The standard enthalpies formation.
Exactly. Standard enthalpies of formation. Standard enthalpy of formation. Each compound or has a standard enthalpy of formation, and it has been calculated for many compounds. Is this clear? But now, as a baseline, the heat of formation, standard heat formation of naturally occurring elements is equal to 0. Clear? This is the baseline. This is where we start. All right? So what's the heat of formation of naturally occurring? How it's available in nature? Like, for example, sodium. How is it available? Sodium, how is it available?
Solid.
Solid. What's the heat of formation of sodium solid?
0.
0.
What's the heat of formation of sodium liquid? It's
We
not
should
0.
measure it.
It's not 0. That's what I wanted to say. It's not 0. Good. All right. What's the heat of formation of O gas?
0.
No. O is not 0. O2
O2 is 0.
is 0. Why O2 gas is 0?
Because it is a natural.
Available in nature like this. All right. How about N? It must be in 2 gas. Good. All right. How about helium?
0.
The gas 0.
Should I put 2 or without 2?
Without.
Without 2. Noble gases without 2. Okay. Good. Now, what are the elements which are solid? What are the elements which are liquid? And what are the elements which are gas? Can you tell? Well, what we're going to do, we're going to go to the periodic table here. Okay, good. All right, so this is our periodic table. In this table, everything which is written solid, black, I mean, most of the elements here are available naturally as solid. So what is the structure of sodium? It is sodium what? Solid.
Solid.
Calcium.
Solid.
Solid. How about chromium? Solid. How about palladium? Solid. Good. Now, that's easy. Now, I will make blue, and I'll tell you which are the elements which are liquid. This one is liquid, which is what? What's this? Cesium.
Cesium.
And francium is also naturally available as liquid. What else? Do you know anything in the periodic table which is liquid?
Mercury.
Mercury is liquid. What else?
Bromine.
Bromine, but bromine is available as a Br2, not Br, but Br2 liquid. That's the only liquids that I want you to know in the periodic table. Okay, there are some other liquids which are not important at all. Good? Good. But don't forget, Br2 is available as a what?
2.
Br2. Good. Now, I'll go for red. Okay. Now, with red, I will put the gases. Where are the gases? First gas is what?
Hydrogen.
Hydrogen is gas. How is it available?
H2.
H2.
What are the other gases?
Helium.
Helium.
The noble gases.
Nitrogen. What else?
Oxygen.
Oxygen.
What else?
The halogen.
Chlorine.
Fluorine. gas. What else?
Chlorine.
Chlorine is gas. What else?
Noble gases.
Noble gas is available as what?
Gases.
One element, not two. Look at the periodic table. As usual, memorize it very well. All right. All of them is gas. These are the gases, and these are the liquids. Look at them at the periodic table. The rest are what? The black ones are what?
Solids.
Solid.
Doctor?
Yes.
I2, right?
Excellent. Yes, I is also solid, I agree, but I is available as I2 again. I2, even AT, and AT is not important, but this is also available as A2 solid. But this is not important at all, but I2 is important. I want you to know this periodic table very well, and it's very easy to memorize. The gases are clear, noble gases: nitrogen, oxygen, fluorine, and chlorine, and of course hydrogen. Everybody knows hydrogen. The liquids is the one that you must memorize, which is Br2, Hg, Cs, liquid, and fraction. The rest are solid. Is this easy?
Easy.
Good. What's the heat of formation of any of these things? Like for example,
Zero.
phosphorus. What's the heat of formation of phosphorus solid?
0.
0. What's the heat of formation of aluminum solid?
0.
0.
And so on and so forth. Is this clear? Any question?
Clear.
Good, good. Now, let's go back. Right. Now, based on this, also, there is another thing. Now, I'll take this away. I hope it's clear by now. So, now, based on this, the heat formation of any element was calculated. What's the heat formation of H2O liquid? What they did, they calculated the heat to make 1 mole from naturally occurring elements like H2 gas plus half O2 gas. And they calculated the heat for this reaction, and this heat is heat of formation of H2O liquid. Okay, so if you want to calculate the heat formation of anything, make it from what? From which elements?
Its constituent element.
Natural occurring.
Naturally occurring constituents or elements. Constituents or elements. All right? That's why if I want to make H2SO4, what's the heat of formation of H2SO4? How can I do it? I have to make a reaction. What type of reaction?
2OH.
What?
H2
2SO4
H2
plus
gas plus
SO4.
S solid.
S solid plus
O2.
O2 gas.
2O2.
2O2.
gas, and I have to multiply it by 2. I want to keep this always as what?
As
One
one.
more.
1 more.
Is this clear? Good. Let's do one more example just to make sure everything is okay. Okay, let's do one more thing. Let's do, if I want to make N2 O3 gas. What's the heat of formation of N2O3 gas?
N2 gas.
N2 gas plus
3/2 O2 gas.
3/2 O2 gas. How easy? Last thing. How about if I want C2H2 compound? What's the heat of formation?
Two S solid.
C.
2C solid.
Solid. Actually, it's solid, but we will always go for-
Graphite.
Yes, because it's available as graphite. Okay, plus what?
H2 gas.
Yeah.
H2 gas. You're done. Very good.
Doctor?
Heat of formation has been calculated for many compounds. So the heat of formation of this one is known, this one is known, this one is known, this one is known, and now it's available for you in table. If you look at your book, at the end of the book, appendices, you will find that there are certain standards. One of them is heat of formation for compounds. So the heat of formation for many compounds has been calculated by scientists. Clear? Now, I want to define two things. What's this called?
Standard.
Standard Enthalpies formation.
Very good. What's this?
Enthalpy for reaction.
Reaction of enthalpy. Exactly. Reaction of enthalpy. All right. And if we are standard, then we put also circle to it. Standard mean under one atmospheric pressure. That's all the standard. All right. It's not temperature. Temperature is 25 actually, not 0. But don't worry about the temperature at all. Okay. Standard is actually 1 atmospheric pressure and 25 degrees C. This is the standard for enthalpy. You remember STP? Is this STP?
No.
What's STP?
1 atm and 0.
Celsius.
This one is 25. Don't worry about it. What I care about, as I said, the heat of formation for many compounds has been what? Calculated. So if I have a reaction like this one, I have the heat of formation of A, I have the heat of formation of B, I have the heat of formation of C, and I have the heat of formation of D. How can I find the heat of reaction? It's actually equal to C, which is this coefficient, times the heat of formation of C, plus D, this coefficient, times the heat of formation of D, minus A, which is the coefficient, times heat of formation of A, plus B, which is heat of formation of, and then heat of formation of B. Is this clear? Or we can generalize it. Heat of reaction is equal to what? Summation of enthalpy of products minus enthalpy of reactants. Don't forget this reaction.
Doctor,
Yes.
what does the N and M represent?
M and N coefficient. In this
Oh.
case, it is the C and the D and the A and the B. That's the N and the M.
Doctor,
Yes.
heat of formation always 0.
No. Everything has heat formation except the standard things, which is naturally occurring.
Oh, okay.
Okay. Now, let's apply this here. We have a chemical reaction now. This is the chemical reaction. Okay. Look, read it carefully. Using data from Appendix 2. See, if you go to Appendix 2, you'll get the data. But Naturally, we brought this data for you. If you go to your book, Appendix 2, you'll find the data available. I want to calculate delta H for this reaction. Can we do it? I give you this information. What's this? This is the heat formation of what? Ag plus, Cl minus, and AgCl. So how can I calculate it? Delta H reaction, don't forget, it's equal to what? Summation heat formation of product minus summation heat of formation of reactant. Keep this law in your mind. Now apply it. Delta H reaction is equal to what? What's the product that we have?
AgCl
So what's the number we have for it?
minus 127.
And we'll keep it as it is. And then what should I write? Minus, and then open parenthesis. And what should I write first? Next.
105.9.
With a positive. And then what?
Minus 167.2.
Okay, what's the answer?
Minus 65.7.
Excellent. What's the unit?
Kilojoule.
Joule for mole.
Kilojoule per mole. Kilojoule per mole. Is this clear? Is this clear?
Yes.
Yes.
Very good. Now, if I write this here, 65.7 kilojoule per mole, and then this means 1 mole of this one with 1 mole of this one will make 1 mole of this one, and the heat will be like this. Excellent. Now, let's combine now. This is the correct answer. I want to combine now His law and heat of formation. His law and heat of formation. First, I want to know what's the reaction that represents heat of formation of C2H2. How can I make C2H2? Heat of formation.
C solid
Yes.
plus H2 gas.
C graphite plus what?
H2 gas.
H2 gas to make C2 gas. That's it?
2C.
Huh?
A 2 in front of C.
Of course, thank you. Yes, I forgot that myself actually. Yes. Can you calculate what's this equal to? Can you tell me what's this value? You can tell from the above reactions. What should you do with the above reactions? Use his law now to calculate this one. What is X? What should I do with the first reaction? The first reaction, what should I do with it?
Multiply by 2.
C plus O2 gas to give you CO2. What's the heat? 2C, 2O2, 2CO2. What's the heat?
Multiply it by 2. Minus 393.5 multiplied by 2.
3.5 times 2. Okay. Should I do anything with the sign? No. Okay.
No.
Okay, good. Give me answer.
Minus 787.
Exactly. Good. Next. What's the next step I'm going to do?
We kept the second reaction the same.
As is, okay, I'll keep it. H2 go plus half O2 to give you H2O, and the heat is no changes, so minus 285.8. Good. What's the next step?
Reverse the third equation.
Reverse the last reaction and do what?
Divide by 2.
And divide by 2. Excellent. You reverse the last reaction, so this will be 2CO2 plus H2O goes to what? C2H2 plus what?
5/2O2.
5/2O2. What will be the heat? I reverse it, so I must put minus, and then I divide by
By 2.
2. So what's the answer? Minus times minus 2,598.8 divided by 2. What's the answer?
1,199.4.
1,199.4.
200. 200.
1,299.4. I'm taking your words. Are you sure? Good. Now, are we able to get rid of everything else? CO2 will go CO2. What else?
H2O.
What else?
O2.
Half O2.
What else? Nothing.
Nothing more.
So what's X?
This is sub between the three heat of formation.
Good. Give me an answer.
226.6.
226.6. I want more than one student to tell me.
Yes, it's the same.
Same?
Yes.
Yes.
Kilojoule. What's the unit?
Kilojoule per mole.
Per mole. Per mole. Is this clear? Any question? I hope so. Very good. And it is 226.6, which is excellent. Good. Very quickly, let's solve this problem. This is just simple Hess law. Hess law. Okay. From these three reactions, can we make the reaction at the top? So what should I do with the first reaction?
Keep it the same.
Keep it.
I will keep it NO plus O3 to give you NO2 plus O2 and minus 198.8. Okay, next. Third
With-
reaction.
Reverse.
Reverse it.
Reverse it, only reverse it,
And divide by 2.
and divide by 2, exactly. So I will make it O goes to half O2, and what will be the heat here? Minus times, yes,
498.8 divide by 2.
because it's plus here, I keep it as the plus as is, divide by 2. What's the answer? I need an answer.
Minus 249.4.
Excellent. What should I do with the second reaction?
Only reverse it.
Why?
Because we want the O3 on the reactant with the
Exactly.
O3 on the
2
product.
goes to O3, just reverse it. What will be the heat?
Plus 142.2.
0.2. Excellent. Now, cancel things. O3 will go with O3. Excellent. Excellent. What else?
O2 with the O2.
3/2 O2 here, and 1.5 here will go away. What
So
else?
this is
Nothing else.
Nothing else. So what's the heat of this reaction?
minus 306.
Exactly, minus 306. How about that? How easy? It is 306. Excellent. Now, let's do this problem very quickly. We have a reaction here in which we have Na2 plus O2, Na2O2 react with water to make what? Help me.
Sodium hydroxide.
Plus
Oxygen gas.
oxygen, O2. Good. Okay. What's the next step you must do before doing any work?
Balance the equation.
Balance the equation. Is it balanced?
No.
No.
What should I do?
Multiply the NaOH by 2.
Very good. What else?
A half O2.
Yes. Half O2 only. Now it is balanced. Now it is balanced because there is 2 sodium, 2 sodium, 2 hydrogen, 2 hydrogen, 3 oxygen in this side and 3 oxygen in this side. So I want to know what's the heat of this reaction. Can we make delta HRXN given the following information? This is the heat formation of all these compounds. Okay, what's the heat of reaction?
Sigma heat of products minus sigma of reactants.
Okay, don't forget this. Yes, sigma enthalpy of formation of products minus summation enthalpy of formation of reactants. Good. Let's have numbers.
So the first one NaOH multiply the heat by 2
times
minus 469.6.
9.6. Okay, or close the parenthesis. Right. Close the parenthesis. How about oxygen? It's not put here.
It's 0.
Yes. Nobody put it here for you because it is 0. So it is 0 and that's why it's not written here. So this is only the other one, or I can put it actually. Okay. Plus, what should I write if I want to put oxygen?
Half 0.
Half 0.
Heat formation of O2. Okay, and then minus, and then open parenthesis. Everything is 1 there. So what is it?
Minus 510.9.
10.9.
Minus 285.8.
5.8. And you have the reaction. And of course, I did not put anything here. Why? Because this is equal to what?
0.
0.
0, because oxygen is naturally occurring, so the baseline is 0. Give me the heat of reaction.
Minus 142.5.
I want more than one student. How many?
Yes,
Other-
I got it.
Same number?
Yes.
Very good. 142.5 kilojoule per mole. Now, I told you at the beginning of this chapter, when you see a reaction like this, how many moles of Na2O2 will react with how many moles of H2O, and how many moles of NaOH will be produced, and how many moles of O2 will be produced? We should say that what? 1 mole of Na2O2 react with what?
1 mole of H2O,
To make what?
2 mole of NaOH,
Mole NaOH and
half mole.
half mole.
half mole O2. Right?
Yes.
Okay, and this is the heat that goes with it. Half mole of O2 is how many grams?
16.
Why? What's the 1 mole of oxygen is how many grams?
32.
32, yeah.
So yes, half mole of oxygen is 16 gram. O2 will give you minus 142.5 kilojoule, right? From the reaction. How about if I have 327.2 gram O2? How much heat it will come out?
It's the same.
No, 16 is giving you this, 327.2.
Minus 2.9 times 10 to the power 3.
2914.
0.125.
Okay, it's 2914 actually, according to my calculation. I'm not sure if I'm right or not, but it's actually 2914.
It's minus, Doctor. Right?
Minus.
Yes, now, I did not put the minus. I said how much heat will come out of the reaction. Should I put the minus or no need?
No need.
No need
No
to.
need.
Why? Because I already told you how much heat come out of the reaction. It's negative. I mean, because it's exothermic, come out means it's coming out, it's negative, but I'm asking about only the heat. So it's possible that I tell you the answer is this thing, 2914 only.
The value only.
The value only. Is this clear? Excellent. Very
Okay,
good.
doctor.
Now, just a second before. Also, I told you that the heat of formation of O2 gas is what? 0. Heat of formation of sodium, what is it?
0.
0. For the elements and the constituent, I told you. For the ions, I want to tell you this only, that the heat of formation of ions is not 0, except one ion, which is H+. What's the heat of formation of H+ aqueous?
0.
0. Only. All right. Based on this, I want you to calculate the heat of this reaction. Quickly.
Minus 84.7.
We have one answer here. Minus 84.7.
Same.
Who got the same answer?
I got it.
Yes, absolutely true. Why? Because what's the heat of formation H+?
0.
0.
That's why. Is this clear? Is this
Gas
clear?
or aqueous, doctor?
I said gas. Oh, mistake. Yes, of course, aqueous. You cannot have H+ as gas. It's aqueous. Thank you very much. I will actually change it right away, inshallah. Okay, good. Now, let's solve this question quickly. What's delta H reaction? I need an answer.
minus 3316.5.
Yes, the same answer.
3316.5. Who else?
Minus 3, yes.
Decided same answer.
Now, should I put the minus or we don't have to put the minus?
If you said it is release, then you don't have to.
I did not say. Now, when you put delta H, you must put the sign. So you must put the minus here. Whether it is released or whatever, when you put delta H, if I say how much heat will come or things like that, then you don't have to put the minus. But when you put delta H, then you have to put the minus if it's minus, and of course plus if it's a plus. Is this clear? And it is actually minus 3316.5. All right, and with this, we finish chapter 5. Alhamdulillah. Okay, any questions?
Doctor,
Yes.
can you go back, I think 3 slides or 4 slides before?
Yes, I will. Let's stop it.